Today we'll be working on lesson 7.3 logarithm and exponential functions. So let's go ahead and start with the parent logarithmic function y equals log base 2 of x. Now if you remember, logarithm was the first function we started talking about asymptotes. And to be more specific with logarithm, we have something called a vertical asymptote. Now to get the vertical asymptote, what you will do is you will set x equals to h, and that will be your vertical asymptote. So remember that the h is going to be inside the parentheses with x, and you always take the opposite of that number. That's how you get your vertical asymptote. Now in this case, we do not have parentheses, and the h in this case is a 0. So x equals 0 will be your vertical asymptote. Now on the calculator, you can check that by going to y equals and plugging in the function that you have, which is log base 2 of x. So you go math, you go 2 steps up to log base, and then that's going to be log base 2 of x. And now if you graph that, you're going to get the graph of the parent logarithmic function. Now remember that the graph on the calculator is going to be misleading because the graph does not stop over here. It continues on forever. Now for you to find the asymptote off of the calculator, you go to second graph, and the asymptote is going to be the first number that would give you an error because the graph will not touch the 0. The 0 is going to be my asymptote, so it's going to be close to it but will never touch it. That's why you have an error on 0, and x equals 0 would be your vertical asymptote. So it's the first error in your calculator. Now let's go ahead and take some points that would be good to graph, like 2, 1 would be a good point, 1, 0, and 4, 2. So let's go ahead and write that. 1, 0, 2, 1, and 4, 2. 1, 0, 2, 1, and 4, 2. These are good points, pretty points to graph. So let's go ahead to our graph, and we can represent the vertical asymptote by a dotted line going through the y-axis. Let's plot our points. So 1, 0. We have 2, 1, and 4, 2. And remember that your graph is going to be close to the asymptote and going through these 3 points. And show me that there are errors on both sides of your graph because it's going to continue on forever. So what would be my domain? Now, as you can see, my graph does not go beyond the asymptote. So my graph will never touch the asymptote. So the domain is going to be from the asymptote all the way to plus infinity. And since the graph will never touch the asymptote, you have to have parentheses around the 0. So the domain is going to be from 0 with parentheses to infinity. The range, however, is going to be from negative infinity to plus infinity because as you can see, the graph goes down forever and goes up forever. So negative infinity to plus infinity, that would be your range. Now let's move on to a transformed form, which is 2 log base 2 of x plus 3. Now again, in this problem, I do not have an h. I don't have parentheses. So the h is going to be 0. So my asymptote is going to be x equals 0 to be your vertical asymptote. The 3, though, is your k. So keep in mind that k is equal to 3. I'm going to write it over here. So the number on the outside is going to be your k, not your h. And since it's, as you can see, it's not in parentheses with the x, so definitely this is not h. Now, you have to be very careful when you put your graph in the calculator, your equation. So when I put 2 log, so math, alpha, math, that's a shortcut, base 2 of x, and this is where students make mistakes. So you see how I only have an x and I have to move over outside the parentheses and put plus 3? Because the 3 is your k, it has to be outside the parentheses. It's not part of your argument. So let's go ahead and graph it. So again, it's so close to my y-axis because the x equals 0 is my vertical asymptote. But remember, this has to continue on forever. To double check, I can go to the table, and I will see that my first error is when x is equal to 0. And that's going to be my vertical asymptote. Now let's go ahead and get some points to graph. So 1, 3, 2, 5, and 4, 7. Let me put that in. So that's going to be 1, 3, 2, 5, and 4, 7. Now I want you to disregard the extra in your table. You're not going to be using that. So let's go ahead and graph these points. So x equals 0 is going to be my vertical asymptote. Now let's go ahead and plot the other points, which is 1, 3. Now 2, 5. And 4, 7. And that will be my graph. Now, as you can see, it's extending on forever. That's why I have arrows on both sides of my graph. Now, again, my domain is going to be from the asymptote to infinity, and the range is going to be from negative infinity to plus infinity, because it's going on forever on the bottom and the top. But the domain, it's not going beyond my asymptote. So my domain, again, is going to be from the asymptote to infinity, and remember parentheses because the asymptote does not touch the graph, and the range is going to be from negative infinity to infinity. Now let's talk about transformation. To talk about transformation, you have to know what your a, h, and k are, and the a in this case is the number in front of the log, which is the 2. The h is the number with the x in parentheses. It's going to be part of the argument. The k will be the number on the outside. So the transformed form, the general transformed form, will look like this. This is how you can tell them apart. Now the a in this case is a 2, so it should be stretched, vertically stretched by a factor of 2. The h equals 0, so that's not going to affect my transformation. My k is 3, so it's going to go up 3. So that would be my graph. Now to explain to you the stretching part, I want you to compare the new function to my parent function. Isn't it steeper and opening more up? It's like as a bigger angle from the x-axis, as you can see, and that's how it's being stretched. That's why you know it is being stretched. Now I would like you to pause the video and try number 3 and 4 on your own. Now I do hope you tried. Again, my h is going to be the opposite of the number on the inside, so it's going to be x equals 1 will be my vertical asymptote. Now to check that, let me put that function in the calculator. I'm going to clear that. And remember guys, it's a negative, not a minus. So that's why most of you, when you put a minus log of x minus 1 plus 2 and you hit graph, it's going to give you an error. So make sure that it's a negative. So math, alpha math, log base 2 of x minus 1. And then I put the k, which is plus 2 on the outside, and I graph it. So this is how my graph is going to look like. As you can see, it's being reflected. It's not usual, because usually my logarithmic function goes from down up. Here's starting from up down, and this is because of a being a negative, okay? Let's go to the y. You see that? A is negative. Now let's go to second table, and I can find the asymptote. It's the first error in my calculator, so x equals 1 is my vertical asymptote. Now let's pick some pretty points, which are 2, 2. So disregard these extra parts of the graph. I'm sorry, you can't see that. It's 2, 2, 3, 1. And what else? We have 5, 0. So these are my pretty points. Make sure that I copied them correctly. Yes. Now let's go ahead and show this on our graph. I'm going to show it with a different color, so I'm going to use the blue. So x equals 1 would be my vertical asymptote. Let's plot the points, which are 2, 2, and 3, 1, and 5, 0. Now if I look at my graph and you look at the points, they're going down. You see that? So you start from the top and you go down through the points and you move on. Now if you compare the blue, so I'm going to put an arrow up there, it means it continues on forever. if you compare these two graphs, you will see that this is being reflected. So this one, the red, because it was in positive a, starts from down up, it goes up, increasing. The other one starts from down and goes from up and goes down, and that's because the a is negative. So if you want to write that down, it would be good for you to remember that, because you're supposed to be able to identify the equations from the graphs, okay? You need to be able to match the correct equation with the correct graph. Now let's move on and find the domain. The domain for the blue one, as you can see, it's still from the asymptote all the way to the right, so the domain is not affected by this reflection, and the range is still from negative infinity to plus infinity. So let's go ahead and write that down. So the domain and range are not affected. Domain from the asymptote to infinity, and the range will be from negative infinity to infinity. Now for the transformation, the a is negative, and that's going to show me a reflection. Now let me zoom in so I will have more space to write. So x equals, what was x? So h is 1. So h is 1. So that's going to go right 1. K is 2. So it's going to go up 2. So as you can see, for the h, I took opposite of the number on the inside. So h, you always take the opposite of the number. And that would be my transformation. Now let's move on to number 4. If you'd like to pause the video and try this one on your own so you make sure that you understand the material. Now the fourth one, as you can see, h is negative 1. So x equals negative 1 would be my vertical asymptote. Now, by now I think, sorry. By now I think you all know how to find the domain and range from your equation. The domain is always going to be from the asymptote all the way to infinity, and the range will be from negative infinity to infinity. Now you can graph it to double check. And remember, negative 1, you should have parentheses there because it's a vertical asymptote. Now, if you look at a, is 3, so it's going to be stretched. It's even going to be steeper than the previous one with the a equal 2. Now the h is a negative 1, so it's going to go left 1, and the k is a 2, so it's going to go up 2, okay? Now let's go ahead and graph it and try to get some pretty points to be able to graph this equation. So 3, math, alpha, math, that's the shortcut, base 2 of x plus 1, move over to plus 2. Now graph it. So as you can see, it's just like the other ones, starting from down going up, and because it's a positive a, as you can see, x equals 1 is going to be my asymptote. So to double check, you can go to the table, and you will see that the first error is going to be at negative 1. There you go. So x equals negative 1 is my vertical asymptote. Let's get some pretty points. And my pretty points are 0, 2. Disregard these extra. And 1, 5. And 3, 8. Let's go ahead and graph it. So let me use a different color. I think purple would be a good color to use. So x is equal to negative 1 would be my vertical asymptote. Now my points are 0, 2, and 1, 5, and 3, 8. Now remember, you start from the bottom next to the asymptote and you go through these 3 points and you go up. There you go. So as you can see, it is being stretched. It's even higher from the red one, which was a equals 2. And because it's going to be steeper, because a is 3, it's being more stretched. You see that? So let's go back to our, make sure that I put everything correctly. Okay, there you go. And that's going to be your graph. Now I do hope that this tutorial was helpful. Please watch the other video for doing the exponential functions.